An IED often is provided as a dedicated box by one vendor hardware with software doing protection, control, and measurement at once. Now imagine lifting that whole device out of the box and running it as software on one powerful industrial server. Instead of a rack of IEDs, you have one server running many of them, each one still walled off from the others, each one still doing its own job. That's virtualization. And each software IED is called a virtual machine. Now, the obvious objection, why not just run it on any PC? Because ordinary software isn't predictable enough for protection. It's fast, but it isn't deterministic, and protection demands determinism. This is where SEAPATH comes in. SEAPATH is a real-time hypervisor. Hypervisor just means the layer that runs those virtual IEDs. Real-time means it gives each one guaranteed timing, so every cycle lands inside the window that IEC 61850 protection demands. That is the whole reason it exists. So here's the mental model. A virtual IED is an IED you can't touch. No front panel, no physical port. It's software, a file you can copy, backup, and move between servers. SEAPATH is an LF Energy project, Apache 2.0 licensed, vendor neutral by design. And last month, it got its biggest update yet. On the 21st of May, the SEAPATH team released version 2.0, release candidate 1. The most significant SEAPATH release in recent memory. It changes how you build it, what it runs on, and what your virtual IEDs can do. One thing up front, a release candidate is a test version. It belongs in your lab, not on a live system. Don't upgrade production to a release candidate. First, the biggest change is in storage, and to understand it, you need to know why storage even matters here. Remember, a virtual IED is just a file sitting on a disk. For that IED to survive a server failure, the file can't live on one machine. It has to live in shared storage, copied across every server in the cluster. So when one server dies, another picks up the same virtual IED from the same storage and carries on. That's your redundancy. It's how a virtual IED fails over, the same way a hot standby scheme protects a physical one. SEAPATH uses a system called ceph to provide that shared replicated storage. Here's what changed. In version 1, you commission that storage using an external set of scripts called ceph-ansible. You ran them from the outside and they wired everything up. Version 2 drops that completely. It uses cephadm, Ceph's own built-in management engine. Instead of an outside script setting up your redundancy and walking away, the storage now stands itself up and keeps itself healthy. You tell it the target state and it maintains it. What ceph does has not changed. Your redundancy works the same way. What changed is how you commission and maintain it. For anyone running a SEAPATH cluster, this is the change that matters most. Second, the foundation underneath. Both SEAPATH flavors got a major operating system jump. On the Debian flavor, that's Debian 12 to Debian 13, a new kernel, new packages, a refreshed base under everything. Third, a small change that bites. The login your tools use to reach the IEDs got renamed. In version 1, it was livemigration, named after one task, moving a running IED between servers. Version 2 replaces it with libvirtadmin, a name that says what it's really for. So anything still logging in as livemigration will fail. Repoint it before you upgrade. Now, what your virtual IEDs can do, or do more easily than before. The software network switch inside SEAPATH gained DPDK on the Debian flavor, a fast lane for network traffic, fast enough for the heavy, time-critical data. Then there's the console. A virtual IED answers on its web interface once it's running, but that's its app on the network. Its low-level screen, for first boot or when the network's down, lives in the IED itself, and the host serves it out to a viewer. In version 1, you add that screen by hand, and the host serves it wide open. Version 2 builds it in. Switch it on, and the host serves it on the local machine only. A virtual IED can now have multiple disks attached on a cluster, something that didn't properly work before. And for protection specifically, there's a change in how the ABB SSC 600 connects to the process bus. In version 1, what I run today, that connection is a shared software-defined path called MAC-VTAP. Version 2 recommends giving the IED a dedicated network card passed straight through to it, so the IED gets that card's hardware directly, including hardware PRP redundancy in silicon. Pass-through isn't new, it's the recommendation that changed.
Start by SSHing into the node, and to be clear, that's the server hosting the IED, not the IED itself. You're logging into the hypervisor. Every command I run is in the description below, so don't worry about catching the exact syntax on screen. Follow the steps here, copy the commands from there. 2 bits of setup. Set the editor to nano, so when we edit, something simple opens. Then alias virsh, the command line tool for managing the virtual machines on this host. On this box, it needs root and the system-wide connection, so the alias saves typing it every time. It only lasts this session. List the machines. This shows every VM the host knows about, running or stopped. There it is. SSC 600 running. Now ask the host what it gave it. This prints the VM's vitals: 4 CPU cores, 8 GB of memory, auto start on boot, real resources dedicated to it, the same way a physical IED has its own processor and memory. Now, the console. Does this IED even have a local screen defined? Everything about the VM lives in an XML definition the host keeps. We print it and filter for the graphics device. That's what gives a VM a screen. Nothing comes back, none defined. So we add 1. virsh edit opens that definition. Find the close of the devices section and paste a block, a VNC display, and a virtual video card. VNC just means a screen you can view remotely over the network. Now read what's in that block and what isn't. No password, and it's set to listen on every interface on the host, so this console is wide open. That's the version 1 default. Let it sit a second, save and exit. A display only attaches on a fresh boot, so restart it, force stop, then start. We force it because this image ignores a graceful shutdown, and it's built to ride out a power cut, so pulling the power like this is safe. A few seconds dark. Is the console actually being served? List what the host is listening on and filter for port 5900, VNC's default. There's the listener, open, no password. In version 2 this is built in and bound to the local machine. Here, it's exposed, now connect. Point a VNC viewer at the host. I'm using tight VNC. Connect to 192.168.0.34. And notice that's the host's address, not the IED's, because it's the host that serves the port. Give it the boot time. And there's the SSC 600's console, the low-level screen you'd normally have to be standing in front of it for. Back to the terminal, how it's wired. Pull the process bus interface out of the definition. One interface, type direct. That's a Mac VTAP. Now cross-check it. Server side, the MAC NC2 5C23. The IED's own network screen, process bus LANA ETH1, shows the same MAC. Same address, both sides. That's the IED's process bus port. It reads disabled at the moment. Finally, is any hardware handed straight to the IED? Count the pass-through devices. 0. Everything rides that one shared Mac VTAP path. The dedicated card pattern ABB recommend for version 2 is pass-through. Roll back to a clean state, redefine from the backup, then restart into it. Confirm the cold open, the graphics device is gone again, and the viewer refuses. Clear the screen, done. With a new operating system underneath and a completely new way of building the storage, moving from version 1 to version 2 is a rebuild. Plan for a clean reinstall. Before you go near it, 3 things. 1. Back up your virtual IED definitions and your configuration. 2. Hunt down anything that still logs in as that old livemigration user because it will fail. 3. If you run a cluster, study the new cephadm process before you start. And again, this is a release candidate. Prove it in the lab. Wait for the final release before it goes anywhere near a live substation. That's version 2.0. What's breaking, what's new, and what to plan for.